Go! And we're on to part 2. So I thought I'd continue with the fun pictures from my backyard for a little intro to part 2 here, guys, only because hilarious to watch these two. This is my lab. Her name is Kana, and she will sit in this spot and watch this squirrel whose name is Sid, right? Sometimes we have a second squirrel. That's why we put up this little table right here. He's not around right now. His name is Tiny. And last spring I made a whole video with featuring Sid and Tiny and making these picnic tables. Super fun. So you can look back on my my YouTube if you want to watch that or see that. There's some crazy footage of squirrels going over GoPro cameras, and it's all set to music. It's kind of fun. All right, so we have a few more problems to take a look at before we close out this video, and then in about, I don't know, half an hour I'm going to be talking to you live on a Teams meeting. So here we go. Yeah, she would sit there for hours and watch that squirrel. Eventually, she sneaks super, super close to about here, and Sid scurries up into this tree right here. Anyway, fun morning times at our place. All right, let's see if I can just delete. I'm not sure if I can. Maybe I can just delete it by hitting backspace. Oh, except for look, I need to erase all of this as well. Okay, so let's talk a little bit about some problems that have to do with function composition, all right? And then we'll round things out today with a little work on conjugates, and we'll leave it at that, okay? Save everything else for taking a look at in class. So here you see that you have 3 different functions. An f of x function, g of x, and h of x function. And if you're trying to find f of h of x, we know that we're taking all of h of x and we're plugging it in anywhere that we see an x in the original outside f of x function. All right. So this means for this particular composition that you're going to have 2 over x minus 5 rolling into that spot. This is one from our workbook. And you're going to be left with 6 over x minus 5. Again, you could get a common denominator of x minus 5 for this fraction and continue to simplify. But if you want to leave it right like that, that's going to be okay as well. And then I think this g of x plus h just means that we are going to plug in an x plus h everywhere in our g function, right, where there's something squared. So that x plus h is going to drop right into that spot. And then what happens on this last problem right here, because we're evaluating h of g of x plus h, we have already found g of x plus h, right? It's right there. It's all of this stuff. So if we can plug that into our h function, this is what that is going to look like. So our outside function, oops, getting crazy here. Things are sliding all over the place. See if I can get it back. There we go. So our h function is 2 in the numerator. And then it's x minus 5 in the denominator, but my value I'm substituting in is all of this g of x plus h. So this is going to become x plus h squared plus 1. We can simplify this, squaring that binomial. Don't forget, you're going to have inside and outside terms on that, so it's going to be x squared plus 2xh. Plus h squared, and then the plus 1 and the minus 5, just like that. Okay, so be careful with your composition of functions and kind of be looking for ways you can continue to simplify. to identify equivalent values. And then I did want to remind you that this is asking for the domains of f of x, g of x, and then the composition. Let's talk about the domain situation really quick. And then let's do a little reminder on inverse functions before our last problem here. So our domain for x squared, right? Our domain here is just going to be negative infinity to infinity. We can plug anything in for x squared, right? So that one kind of looks like that. And then right here for g of x, everything is going to work except for the number 4. So you have this union again, all the way to 4, and then it's going to jump over 4 and go all the way to infinity. Okay, remembering that reason for that is this g of x. If we did plug a 4 in there, we would be in trouble, right? And not be able to actually divide by 0. So that's why that looks like that. Okay, so let's look at the composition. So f of g of x, the composition there is going to look like something squared, so 1 over x minus 4. Everything will get squared. And it still is going to be important here that your x value not be 4. Okay? See that right there? You still do not want to have division by 0. Let's look at g of f of x. See if that kind of changes the domain at all. The outside function g is 1 over some value minus 4, and into this space we're plugging in an x squared. Now all of a sudden, the fact that we're squaring this x squared here is going to give us a positive value. The only time that's probably not going to work is in this range of values where could it be equal to 0, right? What two numbers now, when squared, are going to make this a 4? So this changes our domain. And now our domain goes from negative infinity to negative 2. And we want to hop over that negative 2 and go to a positive 2, hop over that positive 2, and go from 2 to infinity. So you see how the composition can change what your resulting domain is in each case of the original functions and then of your composition. Okay, so there's some discussion there. The other thing I wanted to remind you of is if you are going to, for example, have a function like f of x is equal to, let's say, 3x minus 8. Okay. And we have our g of x, which we think might be an inverse function. So we're turning our attention away from domain and to this idea of inverse function, right? Let's say it is x, oh, where's it going? There we go. X plus 8 divided by 2. Okay, and we're wondering whether or not this might be an inverse function. Well, one way that you can test whether or not you have an inverse function, right, is going to be if you take your original function and evaluate f at g of x. Okay, so my g of x is x plus 8 divided by 2 minus 8. And the goal, remember, as you're simplifying, is to simplify and get in just x. So let's see if that works on this one. It looks like we have f of g of x is going to be 3x plus 24 divided by 2 minus 8, which is equal to 3/2 x plus 12 minus 8. Boy, this is not looking good, right? 3/2 x plus 4. And that's as far as I can simplify it. So you would say, no, this is not a function. However, if in our original function, for example, this was a 3. So let's change this out. Let's make this a 3. That'll make this a 3 right here. And then what ends up happening is the 3's cancel. You're left with x plus 8 minus 8 and a result of x. So if you can simplify f of x, f of g of x and g of f of x and simplify it all the way down till you get x as a final result, then you know that the functions could be inverses of each other. This would be a yes. This over here is a no. Okay. All right, last one, guys. Here we go. We're going to try and fit this one in. I don't know where my last problem went. Oh my goodness, it's gone. Can't even find it. Okay, let's make one up. I have one here. Here we go. This is the one that I had typed in, but I'll just write it in. So we're going to try this complex conjugate. So I had root 6 plus 3 root 7, all divided by 4 plus root 7. And the goal is to simplify. Okay? So because of this plus sign, we cannot just multiply by root 7 over root 7. We have to multiply both the top and the bottom by the conjugate. So this is going to be 4 minus root 7 over 4 minus root 7. You choose the opposite sign here. Remember why that is? Because it's the inside terms are going to cancel as we begin to get crazy with our multiplication here. Now on the top, I got a lot going on. So I'm going to distribute, and I'm going to get 4 root 6, and then it looks like minus root 42. Is that a song or a road or something cool like that? It seems like it might be. And then I get plus 12 root 7. And then I get 3 root 7 times root 7, which is going to be minus 3 times 7, which is going to end up being 21 on the top. And we'll simplify that more in just a second. On the bottom, it looks like we're going to get 16, and then we're going to get a plus 4 root 7 and a minus 4 root 7, and that's what we want. We want those two to cancel, right? That's the goal for that, and then a negative minus 7. All right, so let's keep going here. 4 root 6, not a lot I can do with that. 42, what do you think? 6 times 7, I don't think that is going to simplify at all. My 12 root 7 is going to be as much as I can do with that. And then my 21 here at the end. Okay, so everything in the numerator has a different value underneath the square root, which means they all have to stay separate. And in the bottom, you would have, bump, just 16 minus 7, or 9. And that would be it. That's how you do those kind of guys. Just a reminder. All right, I'm heading off to do a little Teams meeting. I will see you soon. All right, guys, take care, study hard, keep up the good work.